Yeah, so the session is now recorded. So just to reiterate, we discussed on various statements in Yang. So the leaf list, the container, the list. So in this slide, we are seeing a container. So container can contain either or all of these other data types like lists, leaves, and all. And when you do any operation on the container, or when you want the container to appear, it will appear with whatever data types are contained within the container. And when you want it to disable or disappear, the other data types which are part of a particular container will also disappear. And whenever you define a container, and whatever data types you are defining inside the container, so there is a scheme of curly braces you use in the Yang model to do that, just like you do in any language code. Whenever you are doing a hierarchical code, that your braces explains if the code will be executed if the parser enters a particular loop, or if the code is within an if statement, or if a code is within some while loop or something. So in a similar manner, you do all these data types within a container. You define them within a container, and the container is the superset of all these data types. Then you have got list and leaves. So list can have multiple leaf. You can consider the list as a tree, and leaf as its leaves itself. So leaf is the endpoint, the smallest unit that is the data type. It could you can define the type of leaf, the type of data you want to store in a leaf as integer or string or whatever. Then you can use other statements like leaf ref and grouping. So leaf ref is a reference statement, just like you do reference in a linked list. So you are referring to some value for the leaf from the CDB. So you have to give the path of the values from where you want to get them in the CDB. And CDB is your configuration database, an in-memory database which is part of NSO itself, and it stores the NSO configuration as well as the devices configuration, whatever are onboarded on NSO. So list can contain multiple leaves, and those leaves can be of various types. Can be string, can be integer, whatever you define it. Or even you can define a leaf with your custom data type also. You have to define the data type, and then you can make the leaf use your data type. So there are some data types which are already defined in various modules like Yang IETF, or so whatever you import while you create your Yang module, you import some of the modules which are already present. Just like any other language, there are some pre-written libraries, pre-written models, so that one you can use directly. But if you want to create your own, you have to first create your data type, and then you have to refer to that data type while defining the leaf. Create our custom data type based on these data types. Yes, based on these data types. So this is data model and data visualization on Yang. So here you are seeing an XPath to refer data in hierarchy. So XPath is the normal way of referring data within the CDB, and CDB itself is like XML. And like Linux directory hierarchy means you can means the best way to understand CDB is to understand the XML tags, and also to refer to Linux directory hierarchy. You start from the backslash, which is the root, and from the slash you can have user directory, and inside the user directory you have something else, and then you continue like that. So similarly for CDB, there are various trees in the CDB, and in one of our previous sessions, we did discuss on the CDB trees. So most prominent CDB trees which you use most often is the devices tree. So slash devices is the first, I would say, hierarchy within the CDB. And inside the devices, you have device, and inside the device, you have your actual devices like P router 1, P router 2, whatever. So if you want to refer to, and inside the devices, you will have the device interfaces and all. So if you want to refer to interface of a device, so the easiest way will be you go to the CLI of NSO. You reach to a particular point which you want to refer. So you do a show run, and then you continue with slash devices slash device slash your device type and your device name. Then inside that you go to its interface. Then you get to the correct place where you whatever you want to refer. Then you pipe it and you say display XPath. So when you do the display XPath, you will get the XPath of that particular value, how it is stored in the CDB, and you can refer that XPath while creating your Yang models or even the templates to get the value from there. So suppose this XPath slash loopback IPv4. It is slash loopback IPv4 slash loopback or slash loopback IPv4 slash IP address. So loopback IPv4 is one location, and inside that location you have the actual loopback or you have the IP address. So this is in XML sample data. This can be represented as loopback IPv4 tag, and then the loopback is loopback 1. So loopback tag has value 1. So you are referring to a loopback interface, which is the ID of that loopback is 1. So it is loopback 1. And then IP address, you are putting the IP address inside the tags. So whatever is shown in the green inside the tags is the actual value what you are putting, and the blue colored things are the XML tags. So that is how you put it in a device template while you configure the devices. So this example shows you a loopback IPv4, which is a loopback 1, and the IP address you have put in there, and then you are putting another loopback, which is loopback 2, and you are putting the IP address for that one as 10.2.2.2. So in order to visualize this graphically, means if you look at the slide, then you have a leaf list, and list and container. So the leftmost side of the rectangles show what exactly is this data type. So if it is a yellow and L, that means it's a leaf list. If it is a blue L, it is list, and if it is a C, it is a container. So this is how you represent your Yang visually. Means so Yang models, you can do a lot from Yang models. You can create your Yang models, and then you can actually derive a tree in the yin form from the Yang model to make understanding pretty obvious for your models. And when you are talking to different vendors or different OEMs about your Yang model, how you have done your Yang model engineering, you can actually give them, instead of giving the Yang code, you can give a visualization of Yang model. So either you can use this kind of visualization, or there are some tools available within NSO to visualize your Yang model in the form of a tree. So we'll talk about those tools as well. So this one is a leaf. So XPath of this is slash loopback, and the leaf is loopback. Type is integer 32, so it's a 32-bit integer, and then you are defining the range also. So when you define this range and all, so you are giving a check on the Yang leaf, that this leaf cannot have any value other than the range which you have provided. So when the user provides the value for this particular leaf, then it will have a check, and if the value lies within the permissible range, it will accept it. Otherwise, it will throw an error. And the XML data, which is towards the right, is your loopback tag. Within the loopback tag, you have value 1 and the loopback tag closed. So what is happening here is you are defining the variable in the Yang model, which is visible in the left side of the slide. So your variable is loopback. The type of variable is integer 32, and the range which the value it can accept is from 0 to 2147, some value, big value. Okay, so now how do you map this variable with the value? So this is what you do in the templates. So in the template, you are giving a value to this particular leaf as loopback 1. So 1 is the value which you are giving to this leaf. So this is a static assignment of value to the loopback. However, when you do the Yang model and the template together, you can either ask the user for this value, and whatever value the user gives to this leaf, you can map it within these two XML tags, loopback and /loopback. So whenever you put a / and you put the tag in XML, you are closing that tab. So you can put this leaf loopback value instead of putting one static in the template. You can put /loopback as a variable, and then whatever value the user gives to this leaf loopback, it will be substituted in the place of variable which you put. So here in the example, you have given 1 as the static value. Does that make sense? Any questions? Yes.
1 here points to the variable loopback.
So 1 here doesn't point anywhere. Okay, but loopback would point. If you look at the Yang model, then the variable loopback would point to, if you can refer that variable itself within this XML data, you can actually use whatever value is assigned to that variable loopback here. So this is like it's just written here to give you an example that this is how you assign the value in a template, and this is how you do a respective Yang data type for that value. And in the service model, what you do is you take the values from the user, you store it in the Yang data types, and you use those variables in your template, and you push the template towards the device. So that's the magic which NSO does. It's not rocket science. Means it's just like a mail merge which used to happen in MS Word, that you get all the people whom you want to send the letters to with their respective salutation and all, and you prepare a common letter, and then you merge at the right places. You substitute the variable with the different people name, and you send the letter to various people. So it is similar thing happening here in NSO. So Yang model is the place where you model the variables and you get the values for them from either from the user or from the workflow. So workflow is like, workflow can go to anywhere. Workflow is also a piece of code which can traverse and take various activities sequentially or parallelly. So the activities could be either a user activity where you are asking user intervention. It could be asking for a value from the user, or asking to approve something or do something, or maybe go through something and give his inputs, or it could be a system task. So the system task is like, if there is already suppose a MySQL database which has some values stored in it, or maybe an Excel sheet which has some values stored in it. So the system task can actually read that that Excel sheet, or maybe have a listener towards the MySQL, get the value, run some queries, get the value, and then map it with the Yang model variable, and then that variable will be substituted for that value in the template, and template will be pushed to the device. That is the, in nutshell, that is what NSO does most of the time for your service models. There are different other things also which we will talk about, like device life status and all, which is like you can go to the device using the net and do some pre-checks, post-checks. You can define your own commands to push to the device and get the value from the device, and several other things. But the basic is that everything is modeled in Yang. The variables modeled in Yang are substituted for the values in the template, and then both the things are pushed together. So template, yes. So template variables where you define are making reference to the, only the variables are making reference to the Yang model. Template is making reference to the device CLI or device net. Because how you make the template is, you take the exact configuration which is required to provision a service from the network engineer. You try to configure it using NSO CLI, and you convert it into XML. So it is the XML, I would say, representation of the device configuration. That is the template. So, and the first statement which I made was to segregate any configuration given by network engineer into variables and static syntax. So now, is it making sense? Means you can actually join the dots. That first we had the device configuration for a service. It could be, service could span to 2 devices, 3 devices, single device, or 100 devices, doesn't matter. But you take the configuration from the network engineer and then you segregate it into user variables, means the variables where you want the user to give values for. Like for every service there will be different interface, so you need the interface value, that whether it is 0 by 1, 0 by 2, or whatever interface. For various service there could be different IP addresses, so you need the IP address value. Or there could be different pseudo wire IDs or RD, RT, there could be multiple variables. So that one you will have to discuss with the network engineer, that in this service, what all things are you expecting the user to provide, and what all is the static stuff which will go in the device with the value, and the service will be active. So the engineer will help you define the variables, and once you have that, then you have to model it in a way that the user interaction to get those values is minimal. And how do we make it minimal? Suppose we want to create a VPN, and we are asking the user for the VPN number, let us suppose. And number is a variable which we are putting as an integer, means it's an integer variable. And inside the service model, inside the service, we have to use some VLAN, which is also a number. And for in the conversation with the network engineer, you got to understand that for every VPN, the VLAN will be different. So for different VLAN, so for different VPN, there is different VLAN. Okay. So why not you make the VPN number and the VLAN number as same? So you ask only the VPN number from the user, and you make the same VPN number. Suppose VPN number is 1, let the VLAN be 1. If the VPN number is 100, let the VLAN be 100. So with this technique, you are solving two problems that you are just 1 second. Have a call. So yeah. So we refer the variables from the Yang model, and we substitute it at the right place in the template, and that's how we make the configuration for a service. So VLAN was just one example. There could be multiple such examples, like when you are assigning an IP address, then if the third octet of the IP address is same, then you can even make the VPN number as the third octet of IP address also. Means there could be, so that is more of a programming brain which you have to apply on top of the conditions, restrictions, and situations which are given to you by the network engineer. Like suppose for L3 VPN, there could be multiple CEPE links, So for one VPN, there could be one link also, there could be 100 links also. So in the Yang model, you have to make the structure in such a way that VPN is one list, and one list can contain multiple links, and links will also have their own values. Then you create a hierarchical list that VPN is one list, and inside the VPN there is another list called link, so that one list VPN can have multiple links also, and there could be multiple VPNs also. So this became a hierarchy, like there is a big box and there is a small box inside it. So just like you do in programming. So that's how you model it in Yang. Okay, so how the data will be mapped to the template? Very good question. So there are various kind of service models which we can create through NSO. So the first and the easiest model which we can create is a Yang and template based model. So we have the Yang model. We create the template by converting the device configurations into XML format, and wherever there are variables inside the XML tags, we put the same name of variable as we defined in the Yang in curly braces with a slash. So that becomes the variable, and NSO has this logic that when you compile this package, then whenever you are trying to provision that service, NSO, both GUI and CLI, will ask for those values which you have defined in the Yang. From you will have to enter those values, and it will substitute those values in the template at the place where you have put the variables, and it will push it to the device. So that is the Yang and template based service model. Now another way of mapping the values with the variables is with your code. So there are APIs available both in Java and Python, and you can use the APIs to access your Yang model and their respective values. So there is Navu API available for Java, and Magic API available for Python. So with Navu API, you can access your Yang nodes. So there is a inbuilt function in the API, Navu node, and then you can access your Yang nodes, that this leaf, and you can assign values there. You can run logic there. You can go to some other database to get the values, or you can construct your own values. You can go to some other service. You can go to your CDB to check if this is this, then my value should be this. You can do all this kind of logics within your Java code or Python code, but the end objective again will be to map the right values with the template with minimal user intervention. So minimal user intervention is the key. Making a service package is an easy task, but making a service package with minimal user intervention, so you are automating most of the user inputs also. That is where the value of an NSO programmer comes in. So these are some of the attributes of the leaf. So config attribute, whether it's true or false. So if the config attribute in the leaf, just like the range attribute, means you saw that there is a range or there is a type which you can define the leaf for. So config attribute, if it is true, then the user will be asked to give the value for that leaf. If the config attribute is false, then that leaf will be grayed out. Means the user input for that leaf will not be required. So that means, and why do we do that sometimes? Because suppose we have to, we are automating the assignment of some ID in the service package. So, and we are very confident that our code, which we have written to assign a particular ID for a particular leaf, is working absolutely fine. But if we leave that leaf as a configurable value, then while creating the VPN or while creating the service, the user might accidentally put some value there. And then it might override the value which we are giving programmatically. And that might cause some overlap or something. So in order to not to let user give user defined value, you can put the config this attribute of the leaf as false. So in the GUI also, it will be grayed out in NSO GUI. And even if you are creating your BPA template, even I think this logic will be there in BPA. If it is not, it should be there, that when you take the Yang schema, when you query the Yang schema of a service model, and if a leaf attribute is config equal to false, then you should not ask user value, user input for it. It has to be assigned programmatically. Okay. Then you can have another attribute for the leaf called default. So default attribute defines the default value of the leaf. So default value of the leaf is like, if you don't put any value while creating the service for that particular leaf, it will take the default value. Like if the network engineer says that most of the time my interface for every service will be loopback 0. Okay. So you can define the leaf as loopback and default 0. Yeah. So if there is a change of this default, then only the user will put their loopback 1 or loopback 2. Otherwise, just leave it blank, and 0 will be the value which will be pre-populated. In the template, yes. In the GUI, in the CLI, when you are creating the service. So 0 will be, if you are not giving any input, 0 is the means whatever default you have assigned in Yang, that one will be taken. Then there is this mandatory attribute of the leaf, which is like any database or anything. Mandatory true means if you have not given the value to that leaf, then it will give errors. It will not let you go on the next stage. No, someone just mute it. So that is your mandatory. Again, true or false. Then there is must. So must is XPath constraint that will be enforced for this leaf. So when you are creating the service, you are setting the values in the XPath. How? Because you want to write in the CDB, right? You are writing in the CDB. If suppose you are saying the loopback 0 in a service, so you are going at a place in CDB which could be like slash services slash service slash your service name slash this, and then inside there you are writing loopback 0. So you are setting some value. So if you are putting a must attribute, and in the must attribute you are giving an XPath, so the NSO will go to that XPath and check if that value is set there. You need not to give equal to or anything, because XPath is like, if the value is there, the XPath will exist, otherwise the XPath will not exist. Means after loopback, if the ID is ID 0, so if I'm giving a XPath that slash services slash service slash L2 VPN slash loopback slash 0, if I have already set loopback 0 in that service, then that slash 0 will be there. Otherwise, after loopback, nothing will be there. So I can actually check if that value is set at a place, then only it should work. Otherwise, it should not. So that is a must attribute, that this leaf, for this leaf to happen, this XPath should be a must. So you can give a must kind of thing also. So XPath constraint will be enforced for this leaf. Then type is again your data type of the leaf, whether it is a string or it is range or it is this one integer and all. Then there is a when condition. So when condition is also dependent on XPath. So when is like bring this leaf, means get the configuration for this leaf only when something else is true. So it is like an if then else statement, means suppose if you are in Noida office, go to room 5. If you are in Pune office, go to room 6. So you will not want room 6 to happen when you are in Noida office. Understood?
Yes.
So first of all, you will check which office you are in. And then based on that, you will bring up either room 5 or room 6. If it is Noida, room 5. If it is Pune, room 6. So this kind of leaf is like when a particular XPath has this value, then you bring up this leaf. If the value is something else, then you bring some other leaf. So there are situations while defining the Yang models and configuring things that if the protocol is BGP, then you will ask for the BGP configurations from the user. If the protocol is static, you will ask the user for a static protocol configuration. If the protocol is RIP, you will ask, so that there you need the when statement. Then there is description. Description is normal as written in English, means human readable definition of what this leaf does and all. So this is more of a programming best practice, and it's like if somebody else is taking care of the Yang model later on, or if somebody doesn't know what this service does. So description is something which will help to tell what exactly this is for. Reference is again human readable reference to some other element or spec. So if you have, like most of you know about SRDs. So SRD is a document which is prepared, which tells the overall objective of the model and all. So it is more of a design document. So in the reference, you can, give the name of the SRD, that this Yang model is based on the design and the outcome which was mentioned in this document dated this, something like this. Means if you want to know more, you can refer to that document placed in some folder or wherever. Okay. Then units again, human readable unit specification, hertz, MBs, Fahrenheit, Celsius, whatever. Status, whether this leaf is current, depreciated or obsolete. So this is also very clear, I guess. So this is a leaf list. Again, it's defined as a yellow color L at the left side. So the Yang model here towards the left says leaf list loopback, type integer 32, and range is from 0 to some big value. And XML data would be, so there are multiple leaves of same type. So it is loopback 1, loopback 2, loopback 101, loopback 102. So leaf list is a list of leaves of same type, while the list can have multiple leaves either of same or different types. Leaf list is list of leaf of same type. Then this is a container example. So towards the left hand side, we have container loopback IPv4. Then we have a leaf, which is loopback integer 32. Then we have another leaf IP address. So now you look at the curly braces. So this curly brace of container is opening here. Then leaf loopback is opening here. Type opening here. So type closes here. Leaf closes here. So this leaf also becomes the part of the same container. Understood?
Yes.
So now this container I can define a when statement for this container. Suppose that when some value in the X path is this, then only you bring up this container. And if you bring up this container, so you are bringing up leaf loopback and leaf IP address both. Or if you want to disappear this container, then the whole thing means disappears. And in the XML, this is how you are. So there are two values you are putting inside the container. So one is the loopback IPv4 loopback 1. So 1 is the value here, which is given by the user. Then IP address is another value, 10.1.1.1. So this is the IP address variable, which is substituted here. And this is the loopback variable. Leaf list you will not be able to, because you are giving loopback as integer 32 and IP address is INET type. So
it's a leaf. And we can also define a leaf list of the type.
Yes, you can. So if you are addressing multiple loopbacks, then you can put a leaf list there. Why not? This is a list. So list you can consider as a set of variables which you have to define again and again. So if it is like like the example I gave you, that there could be multiple VPNs and inside each VPN there could be multiple links. So VPN itself you create as list. So again, if you have to create a service only once in life, means there could be a service which has to be created only once, then you need not to define it as list, because list is something which you can create again and again. Means you can keep adding the same, means the values in same fashion for similar set of variables again and again. So if I have created a service model for VPN, then there could be VPN 1, VPN 2, VPN 3, VPN 4 till VPN n number, infinity. So I have created this VPN as the list. Okay. So I can create again and again. If I have not created this VPN as list, then my service will only leave, and that value you can only give once. Okay. So list is, suppose Yang, in the Yang model, we have given list loopback IPv4, and then there is a key of list. So key is just like in a database. For a table, there is a unique key. Yes, there is a key which is like unique, and from there you can refer to the list and all. So that key is loopback. Then you can define what values are unique within the list. So IP address is unique. Then you are defining the actual leaf. So loopback is the first leaf in the list. Then its type is int32, range is this. Then another leaf in the list is IP address, and INET type, its type is INET address. And in the XML template, this is how you are defining loopback IPv4, loopback 1, IP address 10.1.1.1. Then again, so this is what I was saying. So this is one time you have done it. Then again, if you want to do it, you have done it again.
That's why you use list.
List, yes. So you can continue adding multiple and multiple and multiple. And of course, each tuple is identified by the key. That is why the key is there. Key in a loopback.
Okay. Mohit, what if if we do not provide a key over there, so does it throw any error, this Yang model, that this is not correct for list or any kind of thing?
We'll have to, we can check it ourselves. We can do it and check it. I don't think it will throw an error. But then what will happen is, okay, it might, because see, when you are defining this list and when you are configuring it, then for all purposes, how you are identifying a particular set of list is through key. So if you don't define the key, how will you identify a tuple? Like if you are
Yeah.
creating the VPN,
Mhm.
you're creating L2 VPNs and you have created VPNs like Airtel and Jio and Voda. So this value name is the key, and that is what is defining a particular set of which is for a particular customer. If there is no key, then what will you bring up when you will say list all the VPNs? So which value will you, or you will list everything? So that will be a challenge there, right?
Right. Okay.
And it says requires one unique identifier key. So requires means it is mandatory. So key is a mandatory thing. While you are defining the list, you have to define a key. Written also requires. Requires means mandatory.
Okay. Thanks.
You can have so it is on your wisdom. Means you have to think what is my outcome, what is my end goal, and how I can achieve the end goal in the most optimized way. So then you make use of appropriate data models. So I can tell you all types of data models which can be used. But when you are the architect, you are solving a customer problem, you are trying to solve a customer problem, then you have to, you are the one, you are the consultant who will define what data type or data model will best suit the requirement, and you put it there. Customer will not even know what is list, what is container. Means his problem should be solved with minimum intervention. So this is a single list key. So there could be single key as well as multiple keys also in the list. So this key refers to a leaf. The key values must be unique. So we are defining a list user and the key is name. So it's a single key list.
जो कल URL मिले ना लोकल है उसमें हमें कुछ पब्लिक बेस URL चाहिए.
So this is a combined key. So you can combine two variables within a list to make a key. So here prefix and length, they both become key. So if the prefix is 192020 and length is 24, so this should be, the combination of this should be unique. And that's how you are making the key for a particular list. So list key and uniqueness restrictions. So at least one key is required. So this is very clear that we need at least one key. A combination of key can be used. So we can say key and we can have various leaves to combine and get the key for a particular list. Other attributes can also require uniqueness. So unique combination of attributes. So unique leaf 1, leaf 2, leaf 3, or we can have individual unique attributes like unique leaf 1. So unique leaf 1, leaf 2 means a combination of these two leaves should be unique. So one leaf can be same for two listings, but the other leaf, if the other leaf is different, so the combination became different. So it is unique. But if you make single leaf unique, that means every leaf has to have a distinct value. So this is list and leaf list attributes. So you can also define how many elements should be present in a leaf. So in some cases, suppose there is a pairing, so or pairing. So if it is a pairing, it has to be between two boxes. It cannot be pairing between three. If that is a constraint, if the network engineer tells you, then you can say the maximum elements in my list should be 2. And the pairing cannot be with the single one. So you can say minimum also 2. So at least user will have to put 2 elements, because user will not know whether I have to give 1 or 2. So if you want to put this kind of restriction, when like in some of the service, if the engineer says that at least minimum I should have these 3 links in order to make a service, any example, then you put the minimum elements as 3. Then you can order by sorted by system or user, means this is like a normal database operation stuff which can be done. Then we have another thing called grouping. So we can use the groupings and we can reuse them. So wherever we are making a group, we can define multiple leaves, containers and all, and then we can reuse the same grouping. Like we have made a grouping here, grouping app, and this is leaf address and port address. So this could be very useful for what Surinder is doing. Means this is like your perimeter security thing. So you always need a source port, a source IP, destination port, destination IP for making a firewall policy. So you can make these 4 leaves as part of a grouping. Okay, and then wherever you want to refer to that or wherever you want to reuse, so you can say container HTTP server uses app. So this whole grouping is kind of reused here. It is like you made a class and you refer it. It is normal reuse. Then another type is leaf ref. So leaf ref, as I explained, it can be referring to a particular XPath, and you can fetch the values from there and can assign the value from a particular XPath for a leaf. So in the example here, we have list services, key IP port, leaf IP, type inet, and leaf port, type inet 16. Abhi, we have this container app. You have a call? Okay, please carry on. So we have this container app. So leaf address, type leaf ref. So now we have defined the type of this leaf address as leaf ref, and then with the leaf ref type, we have to give a path also, that leaf ref. So we are referring something. So what is the path we are referring? So here we are saying /services/IP. So from here it will go to the CDB. It will traverse the tree /services/IP. Whatever is available there, that will be equated to this leaf. Then leaf port. So /services. Then so this is the way how you make regex, how you make XPath expression. So XPath expression also, there is a standard of how to refer the XPath. So it is /services, then you are opening bracket. So you are saying IP equal to current. That means there could be multiple IPs there. So whatever your Yang model is traversing, so whatever is the current leaf that time, means whatever is the current IP which you are working on, so that one is current, and under that current, because there could be inside the IP there could be multiple IPs, 10 IPs are there. So which IP you will go inside? So it is saying IP equal to current. Current is like function, it's like systime function. When you sometimes say no, time equal to systime bracket open bracket close. So that means the time at that particular time. So it's current, then slash, then dot dot. So dot dot means you're going one step above, then back. Yes, above or back. Then you're saying address and port. So this is how you refer the XPath. And if you, so you might have a question that, how do I know this is the exact XPath? So I told you, go to NSO CLI and try to traverse, try to traverse to the exact location where you want, then pipe it and say display XPath, and you will get the XPath. And of course, these ones you have to know that where which kind of bracket needs to be used and how the function needs to be used. This one you should know. So XPath, we already were speaking about XPath. So XPath is path language defined by WC3. So you can put this WC3 on Google and you will get some documents on how XPaths are defined, path language, how it is defined, what brackets, when they are used, what do they mean. You can read about that. Uses expression to reference or extract parts of XML document. So that's what I told you, that CDB itself is XML, and you are referring to or extracting some part of CDB using this XPath expression. That is what it does. WC3 is the specification for how to do that. It also contains a number of useful functions for numbers and strings. XPath uses XPath 1.0, that is the specs for XPath 1.0. Then leafref, referencing leaf or leaf list value in data tree. When and must statements to add constraints to data model definition. So again, XPath expression addresses an XML document and return a result that can be either a node set, could be a string, could be a number, or could be either true or false. So this is an example where XPath is referencing all interface IP address. So XML source is loopback name 0. So it is referring to loopback 0. Then IP address is address primary, and this is the, so this is part of your CDB. You can consider your CDB will be like this for a particular device. So it is inside the device, you are going to loopback 0, and IP address for that is this one, subnet mask is this one. Then you are closing the IP address, then you are going to, you are closing the loopback. Then there is another interface. So this is not loopback, this is gigabit Ethernet, then 0 by 1, and this is the IP address. So you want to get the IP address for all the interfaces of a particular device. So how you do the XPath? So whatever is the device, so that one I'm putting an asterisk here. So asterisk means because I don't know what is the device, so I have just ignored that that part. So I have to go till the device, and then after the device, I'm saying IP slash IP slash address slash primary slash address. So IP slash address slash primary slash address. So IP is here, address, primary, address. And whatever is before that, I'm saying star. So star matches everything.
That means current IP address, like whatever the IP is, like star.
पीछे कुछ भी है वो वहां तक जाएगा जहां उसे मिलता है IP slash address slash primary slash address. ये जहां जहां मिलेगा, it will get you those values. Or instead of putting the star to match all, you can put 2 slash. So 2 slash also it means whatever is behind, don't care, match everything. You have to go till primary slash address. But this can lead to, if wherever it will find primary slash address, whether it is desired or not, it will give you the value. So this is what it says here: use slash to match descendants at any level. use wildcard star to match any element at a given level. Use directory like path to address a hierarchy in the XML document. This is another example for all GE interfaces. So we'll close here for today, and I would recommend all of you to create at least one Yang model. So I can give you an exercise on creating a Yang model for an L2 VPN. I can give you the configuration, and then you have to create the Yang model and the template. And I will not give you the solution. I'll just give you the problem, and also will help you to give you constraints and to define the variables, that what are the variables. I'll give you network configuration, and you have to do it for iOS and iOS XR, and I'll help you defining the variables and all, and then you will have to come up with a Yang model and respective template. And once you have it, so in one of our previous classes we discussed that we have this ncs-make package command where you can create the service skeleton. So once you create that and you put the Yang model and the template at the right place, you make it, and your service will be ready. So it's more of I would say now personal exercise which you'll have to do. I'll create an exercise and will send on emails for all of you, and you'll have to come up with the Yang model and the template. I'll define the nets and everything. So let's see how it goes, and ask questions wherever you're stuck. Ask questions. Okay, so thank you very much, and all of you have a wonderful day ahead. Thanks, guys.
Thank you, sir.